Hello world, welcome back to another video. In this video we're going to keep doing some Leetcode challenge, and for all the Leetcode video from now on until certain point, we're gonna try to work on to work on this algorithm one, like a crash course. I think they have. I think it's pretty interesting to see how everything's structured. So we'll go and get started on the very first challenge, which is binary search. If you don't know what's a searching algorithm is basically a way for you to find the index of an element in a list. That's the most practical example of a searching algorithm. And there's multiple searching algorithm. One of the most common one is called binary search. Yeah, binary search. So this binary search, how it work is, let's say it's have a prerequisites, like precondition, is a list need to be sorted in any order, ascending or descending. All right. So this is a list is sorted like this. All right. Let's see. That's our list. And for example, we want to find what's the position of 4, for example. How would it work? Well, since this is an odd element, we'll check the center. I will check the center first. All right. And then for example, if the center value will be, if it's a less than 4, that is basically the center right now. If it's less than 4, then we'll search the right half. Otherwise, it will search the left half. So it eliminates basically a half of the elements at once. And then we'll do the same thing here. 3, 4, 5. What's the element? Well, 4. So it will return 4, for example. Or not return 4, it will return the index. So we'll always keep track of the index as well. So that's kind of the logics, and let's see if we can implement it in Leetcode. So in this case, we have a sorted list already. That's that, and everything's going to be unique, and it's in ascending order, which is this order. There are also a scenario where if it's even, right, which will work similarly. All right, so let's go and get started. So we'll first have a mid. That's going to be the middle index, right? And then we can say let's just say equals to length of nums divided by 2. That's going to automatically round down as well. So even whether it's even or odd, right? So then in here we can say, well, true if mid is greater than target, then we want to say mid equals, okay, so then we also need a left, which is 0, right, which is length of nums minus 1. Right, so that's that. So if mid is greater than target, let's see, what do we want to do here? If mid is greater than target, then mid equals to if it's greater than 1, search the right half, which then wants to left to mid, right? And then we can say mid equals left plus right divided by 2. Else if mid is less than target, no, I messed up the order here. Mid less than target, mid. Then if mid is greater than target, wants to go left, So left will equals to 0. That won't change. Right would equals to mid, and mid would equals to left plus right divided by 2. Else we will return the index, which is mid. Basically mid equals to target. Let's see would this work. I'm somewhat doubting it will work. Oh shoot. Okay, so that means it's bad then. Okay. Let's go through this. See what's wrong with our logic. It's probably something wrong with inclusive exclusive, how it works. Let's take a look. Oh shoot, we can't say it like this. We have to say nums bracket mid, not just mid itself. Yeah, because mid is the index. Nums bracket mid can actually give you this real thing, where our real index we're looking for. Oh, I think I already did this challenge. Well, I don't even remember. Alright. Apparently. Oh, I did it in Java? I don't remember. Anyway. Let's read the details really quick. Alright, so -1, 0, 3, 5, 9, 12. We're looking for 2. Okay, so then here we can't say while true. We have to add another stop mechanism. Let's see. Let me, okay. I'm gonna see if I can copy to this whiteboard here. That's our list, and we're looking for 2, right? So based on our logic, how would it work? Is this left is 0. Left is 0. Mid at the start will be 3. Right? And then right will be 5. Right will be 5. Okay. And then we have this while loop. So if num bracket mid, so 3, 0, 1, 2, 3, that's 5. 5 is greater than 2, greater than target. So right will equals to mid. Okay. Where is it? All right. So right will equals to 3. Left will still be 0. Right, okay, I'm just gonna write letters. Right will be 3. Mid will be 1. Yeah, and then we check. Okay, 1, 0 is less than 2. Right, there is less than 2. Oh my, okay. Left is mid. I'm gonna have to write out in a different way. Left equals mid. Right equals, and mid equals 2. Okay, then we're stuck here. Well, 0, 1, 2. 2 is 3. Right? What's going to happen? Well, mid. Well, 3 is less than 2. So left would equals to 2. Well, we can say this. Previous. Oh, let's do a previous here. I can say previous is 0. And while mid is not equals does not equal to previous. Let's see. So this forces it to only run what 1 times, I think. And we'll return negative 1 at the end. Alright, gonna set to negative 1. It cannot be negative 1. So it has to work. Because it cannot be negative 1. Right? No way the index is negative 1. Oh my god. Alright, what's happening here? So left is 0, right is 2, so give you 1. Okay. This one, let's see. Let's try to get this one to work. I'm really bad algorithm in case you haven't noticed yet. But I guess that's why I'm doing these challenges. Alright. So negative 1, 0, 5, right? As a start, L is 0, right is 2, mid is 1. Yeah, mid is 1. So then here, what did we do? Okay, well, mid is not prev, so prev is negative 1. So mid is not prev, it's gonna keep running. Prev equals to mid, alright. So now prev is 1. Okay, if num mid less than target, 0, yes, 0 less than 5. Their India is less than 5. So mid going to be left plus right. Left. So left will be equals to mid. Oh. Okay. Well, left equals to mid. Right equals to 2. But then that will still give us 1. Maybe we can't do minus 1 here. But then would it mess up the order? Never mind, I guess it works. Alright. Pretty slow, but you know, I guess it works. So we have left, mid, right? Right? So it looks like we don't, because the exclusiveness, to just get rid of the minus 1. store the previous mid number in there, because we don't, once it repeated would give us the same mid number, then we can just assume, okay, it's -1. And then that's just, this part is just the shifting left, shifting right thing that we used. All right, perfect, that's that. Let's take a look at the next challenge we'll do. Wonder if we give you a little check mark or something. Perfect, completed. All right, first bad version, let's see. I feel like I did this one too. Not sure. Let's look it through. We'll just look at it. If it's not too hard, we're probably gonna do it in this video. Otherwise, we're gonna make a new video about it. All right, let's see. You're a product manager and leading your team. Oh, yeah, I think I did it. Oh, never mind. I did it all in Java. All right, let's see. Probably can do it in one video. You're a product manager and currently lead a team to develop a new product. Unfortunately, the latest version of your product fails at quality check. Since each version is developed based on the previous version, all the versions after bad versions are also bad. Suppose you have n versions, 1 to all the way to n. You want to find out the first bad one, which caused all the following to be bad. You are giving okay. So we could use the Boolean search, not the Boolean search, the binary search we implemented. One way we just do linear search, right? We just go through all of them, subtract, loop this through, right? We can do something like for I in range of n, right? And then we can say, okay, want to do that because that's an order. And then here we can say if is bad version I, right? Return I, else we could just return. Else we don't want to return anything, right? Probably. I'm assuming it's always going to be a bad version. So that's a linear search, right? Obviously that will work. But even if in the past I want to implement using binary search, I think it's not going to pass. Because the problem maker probably want us to use a different, time limit exceeded. See, that's too much. All right, let's try binary search. See what binary search work. Right, so let's just define binary search. Since we already implemented, why don't we just copy the code? Yeah. Actually, don't need to define another method. All right, so left is equals 0, right is equals 2. All right. Now, the thing, okay, it might not, no, it works. So we can say if nums, so basically it can only shift right? It can only, no. Okay, if we were implementing using binary search, that's a little bit risky. Okay, so we could do binary search. If nums mid shift left, then that means, okay, we want to do this. probably don't want to really generate a list. You know what? Let's do this. Instead of doing links of none, we can just say n. Well, this is n. And then here I can just say right minus left divided by 2. All right. So while mid is not equals to previous, which I think would never happen, but we're just gonna have that check anyway here. Previous middle. All right. So then, if is bad version mid, does that mean if it's true? No. Want to shift left, then we need to do this. If, yeah, because we're changing right. If we're shift left, we want to keep the left the same. So if is bad version mid, if not is bad version mid. Okay, I'm hoping Boolean search will make it, or binary search will make it quick. Yeah, at least will be 2 times quicker. Probably. All right. However, in here, what we probably want to do is, in order to return, we need to check this. If is bad version mid minus 1 equals false, right? Then what we want to do is return mid. So I want to make sure the previous bad version is not bad, but this bad version and is bad version. Okay, we can just indent that. So I don't have to check this anymore. Huh, I think this looks good. Let's try it out. See what will happen. Oh. Rookie mistake. Don't know why. Probably delete that. But alright. Let's try. Alright, see what happened here. I'll put -1. Probably not the best way to deal with it, but I don't know if there's any other edge case. Okay. Do I need to go n+1 here? Something. Oh, okay, I guess it works. So yeah, we use binary search. And then since I'm supposed to shift right, so you want to have an extra one at end. Yeah, that's that. Okay, we'll finish that as well. Refresh the page. All right, it's actually not that bad. Not that bad. I think if you guys are really interested, I could also purchase premium, that we can do some premium questions as well on Leetcode. All right, let's see. Search insert positions. Probably gonna do this in the next video, but I'm just gonna look at it really quick. All right. Given a sorted array with distinct integers and the target value, return if the index. Okay, so it's kind of like binary search, right? Big O of log of n. Probably is a binary search. However, it's not just binary search now. Is we also need to add something to it. All right, there's a trick to it. So actually, I don't think it's gonna be that hard, probably. Okay, I think to make it, we can reduce the redundancy here. Okay. Probably return mid here. Yeah. Let's see. Zero? Probably need to do mid plus 1. Okay, wait, what? Okay, if mid is less than target, okay, we don't wanna. Now let's see if we can figure this out. Probably gonna be a little bit too long. All right, so if the input is 2, let's see what happened when we have 1, 3, 5, 6. Looks like these 3 times all about binary search. Let me dial this down a little bit. We're looking for 2. All right, so what do we have here? 1, 3, 5, 6. So then, based on our binary search, left is 0, right is 4, mid is 2, prev is -1. Right? So first of all, prev is 2 now. Right? Okay, so 0, 1, 2, 5. 5 is greater than 2. Therefore, it should shift left. Right? So yeah. So we are setting right equals to mid. And then what left doesn't change. And then mid, after we're recalculating it, it'll be 1. Yeah. Okay. So then, okay, it's really about how do we find which position to insert then. All right, let's see. Then m is 1, 3, right? So previous is equals to 1. So what happened here? Well, 3 is greater than 2. It's going to have to shift left again. Right equals 1. Left equals 0. Then mid going to be 0. Okay. Previous is 0. 1 is greater than 2, therefore we're going to make right equals to mid. right is 0. Left is also 0? Okay, wait. Right equals to 1. Left equals 0. Now will definitely be 0. So that will cause an error. Let's say this. If mid, num bracket mid is less than target, then we probably return mid plus 1. Otherwise, return mid. Oh, there we go. Guess it works. Guess we just need to fix the shifting. All right, perfect. So, it's actually a pretty productive video compared to some of my other Leetcode videos. So finish all 3, probably because we really just reuse the binary search algorithm over and over. Yeah, I think that's pretty much it. All right, so if you have any questions or comments, feel free to comment down below. And this is basically what we will follow. Keep working for each Leetcode challenge video, but then we're also going to have some project video in between. But yeah, if you have any question or comment, feel free to comment down below. As always, stay safe and have a great rest of your day. I will see you in the next video. That's me, out.